All right, guys, so going to go ahead and cover 7.6 today. This will be our last lesson in Chapter 7. So we will switch gears into review mode after today. I think I had kind of said, and I was wrong when I said this, that we would test middle to early to mid next week. We'll probably test Friday instead. Okay, so a little bit ahead of schedule. Okay. But this is our last lesson. Yes. Well, you can. I mean, I'll post it. Wednesday on Google Classroom, and you could come by to grab it if you wanted to. But it'll be online. Wednesday. So I may make those available tomorrow too. So if you want to work ahead. All right. So anyway, 7.6 natural logarithms. This is really just an extension of what we've been doing as far as our logarithmic and exponential equations. It's just kind of dealing with a new base. So just some things, hopefully, that you're aware of at this point. Just some inverse relationships. So like 2 to the x and log base 2 of x are inverses, and then you see a few other examples. So our new thing today is that log base e of x is called natural log of x, and its inverse is this guy. Okay, so e to the power of x and ln x are inverses. Okay. So again, I think this is probably the key thing that I highlighted, right? Log base e of x, it's never written out that way. It's always written as natural log of x, okay? So that's the key. Other than that, it's the same kind of problem we've been doing, okay? So before we get into some solving, we are going to, see how our properties of logarithms apply to natural logs as well, okay? So example 1a says in at first. That should be an L. That's just a typo. So change that to an L. And then so example 1 wants us to do, what is each expression written as a single log? So this is going to be natural log of something, right? So then we apply the same rules we've done with our logs, right? So addition means that we multiply powers. And any coefficient is like a power of a power. Okay, so then overall this would be natural log of 7 times 5 squared. And then we just simplify that. So 7 times 25, or 7 times 5 squared, is 175. So this is natural log of 175. And on this one, since we don't have any variables or anything in there for our powers, this is a good one to show you on your calculator that this is true, okay? If I type it in the original way, natural log, so that button, it literally says ln. It's right below the log button. So natural log of 7, I'm going to close those parentheses, plus 2 natural log 5. Like, we have no idea what that's going to be, but we'll just let our calculator tell us. So it's like 5 and change. Now let's see if that's the same thing as the natural log of 175. And it is, right? So that just kind of confirms that, this stuff works, okay? So let's do one more together, and then you can try one. All right, so again, we have a couple of coefficients that will, be a power of a power, and our operation to the exponents is subtraction, right? So we'll have natural log of x cubed, and then subtracting exponents means dividing powers, so over, let's see, the quantity 2x squared. All right, now we can simplify that fraction a little bit, but that's the main thing that you know it's equivalent to what I just wrote out. So natural log of, x cubed over, that would be 4x squared. And then usually you're done at this point, but I can simplify x to the third over x to the 2 as x to the first over 1. So final answer here, most simplified answer is natural log of x, or x to the first over 4. Okay, so you guys go ahead and try this one. It says 3 natural log of x plus 2 natural log of y plus natural log of 5. So give it a shot, and then I'll put up your single natural log here in just a sec. Anybody want to take a stab at it as we get close to the buzzer here? Come on, you could be forever immortalized on a Mr. Jenkins video here. This is a once-in-a-lifetime chance. Ethan? That's it. X cubed times y squared times 5. Which usually, we would write as natural log of 5x cubed y squared. But, what Ethan said is exactly right, okay? Anybody have any questions about those? So that's nothing new, right? Just natural log is the only kind of new thing. Well, all right, so let's go ahead and solve a couple of equations here that have either natural logs or e to the power of something in them, okay? Before we do, I didn't leave you much space up top there, but what little space I gave you, let's go ahead and write a couple of important kind of properties, okay? So just important properties. Okay, so don't really worry about y right this minute, but one thing that you should know is the natural log of e to the x. And we might revisit why this is true. But the natural log of e to the x is equal to x. Well, we could talk about why that's true. That is true because, another way to write that would be x times the natural log of e, right? And basically that just means x times 1, okay? So that's why it's x. And then another one that's a little bit tougher to see, but that's e to the power of the natural log of e to the x is equal to x. Okay, so I actually don't really refer to these that much when I work through these because I'm more take an approach where I'm gonna solve this the same way I'm solving the ones that I did in 7.5. So that's how you'll kind of see me work through these, but we may use those properties from time to time. Okay, but let's try to make it as simple as we can, right? Keep it as much like 7.5 as we can. All right. So directions in this back page are to solve and then do that, go out 4 decimal places like we've been doing, okay? All right, so A just says the natural log of x is equal to 2. Natural log of x is equal to 2. So I think it's easiest just to think about, another way to write this. So I'm going to just say also known as, instead of natural log of x, you could think of it as log base e of x. Okay, so if I write it that way, that just helps me to go into exponential form at this point, right? I have my logarithm isolated, so now I go to exponential form, just like we did on our warm-up, okay? So in exponential form, this would say e to the second power is equal to x. E to the second power is equal to x. Right? And then the last thing we have to remember is, you know, that kind of looks like a lot of variables, but e, remember, is a button on our calculator, right? That's an irrational number, just kind of like pi. Okay, so we just use our calculator to evaluate the left side. So remember, to get e, you hit second and the ln button. So it says e to the power of, we want to know what's e to the power of 2. And so just 7 and change out to the fourth decimal place would say 7.3891. All right. So let's do, I was going to leave B for you guys, but B is a little bit tougher. So let's do B, and I'll leave you guys C. Okay. So another natural log equation. Okay. So if I write this as base E, and again, you don't really have to do this. It just helps me go to exponential form for whatever reason. Okay. So log base E of 3x plus, sorry, I'm doing that wrong. That's not what it would be. It'd be log base E of what? Anybody? 4, right? Am I doing that wrong? No, I am doing it wrong. Sorry, just kidding. It would be log base E of, I was skipping ahead a step. I'm sorry. Log base E of 3x plus 5 squared equals 4. Sorry about that, guys. So now we want to go to exponential form. That's what I was getting that step mixed up in my brain. All right, so in exponential form, that would be e to the fourth equals the quantity 3x plus 5 squared. Anybody have any questions about that step? Kind of going from here to here. Is everybody good on that? And again, you see how it's just like 7, 5. Just a weirder number, base E, right? All right, so if I'm solving this, okay, now think about what would make sense to do here, right? So your first thought might be, okay, I can take 3x plus 5 times 3x plus 5 and then get a quadratic on the right side. But that's really not going to help us, because on the left side, we don't have like an easy number to deal with. We have an irrational number. So instead of multiplying this out, what we would do is just go ahead, we can just square root both sides to get rid of that exponent, okay? So that would be a kind of a key difference to what we do on some of the others, okay? So when I square root both sides, this is super easy to forget, but it's plus or minus square root of e to the fourth, okay? All right, so what's that give me? That gives me plus or minus e squared on that side, and then on the other side, just 3x plus 5 to the first power, so 3x plus 5. It is, so Ryan said, why isn't it plus or minus on the other side too? It technically is, but it's just a lot easier way to think of it if we just put it on one side, okay? So it just makes it a lot simpler, because it looks like a lot more possibilities the other way, but it ends up being the same. So good question. All right, so then we'll go ahead and try to get x by itself, and then get into how we punch this in on our calculator, okay? So minus 5 to both sides. So I'd have negative 5 plus or minus e squared equals 3x, and then divide by 3. So negative 5 plus or minus e squared all over 3 is equal to x. All right, so let's go ahead and try to type these in. And I don't know if it's easier to maybe go step by step, but this is how, the way I have it, this is how we could type it in. What you got, Andrew?
When's the test over this season?
Friday.
Okay.
Yeah. All right. So -5, we'll do plus e squared. So that's plus, and then second ln. And then I'm going to close my parentheses, or I could just hit equals and then divided by 3. That'd be fine too. But I'll close my parentheses and hit divided by 3. So that's going to be point, and we'll go 4 decimal places, 0.7964. 0.7964. So we'll say one of our solutions is 0.7964. And then our other one, where we do minus e squared, is, well, let's see. So another approach to typing it in would be, you could go -5 minus e squared, and then just go ahead and hit enter, and then divide by 3. That might be easier than using the parentheses. Either way, though, on this one, we'll get -4.1297. Okay. Now, if you have the thought here, Mr. Jenkins is going to say we can't log a negative. That's a good thought. But in this case, the reason that this is a solution is, you know, if we go back and plug in the -4 number here, it ends up being that you know, we get a positive when we square. Okay, so you know, 3 times -4 plus 5, and then you square it, it's positive. So we're actually logging a positive there. So this one is a little more confusing, but both of those are solutions on this one. Okay, so we'll box them both in. So that one can be really tricky. Okay, all right. So probably not a great one for day one notes, but that's all right. All right, so I'm going to leave Steve for you guys to try in just a second. So let's do D and E, and then we'll see where we're at time-wise after that. Okay, so D, E, and F look a little bit different, right? Those are e to the power of something. Okay, so let's see how we can solve these. All right, so if it's exponential, then we usually convert to a log to solve, right? So that's what we'll use that same strategy here, right? So as a log, this would be log base e of 12 equals x minus 2. Okay, and then again, log base e of anything is just natural log, right? So we say this is also known as ln of 12 equals x minus 2. Okay, and again, why does that help us? That helps us because this is something I can type into my calculator, right? My calculator can do that for me, okay? So what I'm going to type into my calculator is natural log of 12. Add 2 is equal to x. So natural log of 12, close parentheses, plus 2 is 4 and some change, so we'll call it 4.4849. And then again, I know I don't show this every time, but it does take some skill to just plug that back into check. So I'll just show that once here. So e to the power of x minus 2 is supposed to be equal to 12, right? So if I want to type that in just to check, to pull up e to the power of second and ln, x, so I'm going to input my answer here. So that's second and negative. So I'm going to do answer minus 2 as my exponent. And this is supposed to be equal to 12. So I'm going to hit enter and hope I see a 12. Okay, and you can see that I do. Okay. All right, let's do one more of these together, and then we'll see where we're at time-wise after that, okay? All right, so looking at E or F, you do have an extra first step, okay? You don't want to go from exponential to log or vice versa until you have the exponential or log isolated, okay? So on E, like we'd want to divide both sides by 2 first, okay? So we'd rewrite it as e to the negative x equals 10. So just dividing both sides by 2 there. Now we can go to log form, okay? So log base e of 10 is equal to negative x. So we just write that as ln of 10 is equal to negative x. Natural log of 10 is equal to negative x. Now you could say I'm going to divide or multiply both sides by negative 1 to get me to negative natural log 10 is equal to x. Okay, and again, we can just type that into our calculator at that point. Negative natural log of 10 is going to be about negative 2.3026. All right, so what I'll do now is I'll go ahead and let you try to work on the couple we left blank, and I'll go ahead and post your Math XL assignment. And hopefully before the video is over, I'll have time to work C and F, okay? Tomorrow, we will do like a Q&A day over this stuff. So if you want to save your homework, you can. Or if you want to work ahead, especially you juniors who will miss the day I pass out the study guide, you know, if you're pretty well caught up on your homework, I'll go ahead and give you the study guide a day early there. What time do we get out of here? Okay. Yeah, guys, so what I'll do is I'm going to go ahead and actually just stop the recording here. So I would recommend, you know, up to the bell, you try to do those 2 equations, and we can revisit them tomorrow, or you can check them on your filled out notes, but we may come back to those tomorrow. Anyways, last lesson, so we'll switch gears after today into getting ready for the test.